Hey guys, today let's solve the binary tree level order traversal problem. So, this is the given problem, right? They are giving us the root of binary tree and we need to return the level order traversal of the node value. In example from left to right, level by level. Let's take a look at the example 1. Let's say the given input is like this. That means on the level 0 we have node 3, right? On level 1 we have 9 and 20. On level 2, we have 15 and 7. So, the expected output will be looks like this. On the index 0, we have 3. On the index 1, we have 9 and 20, right? On the index 2, we have 15 and 7. Well, what if the given input is only have one node? Well, we will just simply return the node in level 0. Then what if the root is empty list? We will just simply return empty list, right? Let's take a look at another example. Let's say the given input is like this, 1, 2, 3, 4, 5. That means on the level 0 we have not 1, right? On the level 1 we have 2 and 3. On the level 2 we have 4 and 5, right? So the expected output will be looks like this. So the goal of this problem is to return all nodes on each level by level, right? And using BFS will be more suitable to solve this problem. Why? Because BFS are visiting all nodes at the current level before we move to the next level. And on here, we can solve it using few solutions. The first one is BFS. The second one, we can use DFS. I think we can use DFS iteration with one step. Then can we solve it using recursion? I think yes, we can do that. Option 3, we can use DFS recursion. Let me highlight this first. So on here, if the root is null, return empty list. We need to create queue because BFS are using queue, right? Create queue and push the queue, push the root with level into the queue. I think we don't need the level as well. I think we just need to push the root to the queue. Okay, then while queue is not empty, then this one will be return the result. We need to create the result as well. Create result, create empty list as the result. Then while queue is not empty, right? Get the queue size from the queue. Look through the queue. Then this one, push the level node to the result. On here we need to create level node to store all nodes on each level, right? Then inside of the loop we get the current node from the queue. Then on here we need to push the current node into level node. If the current node have any child node, either it's left or right, we push them into the queue. I think like that's all. Let's see. Let's say the given input is like this, or maybe we can use this too. Okay. Then at first we're gonna start from queue is the root, right, which is queue is starting from 3. While queue is not empty, which is true, we get the queue size, right, which is 1. So we're gonna start from let E is 0, E is smaller than queue size, which is true. So we get the current node, right? The node is not 3. Then queue is first in first out, right? So we're gonna use shift because queue is V4. Then now the queue is empty list, right? Then we push the current node to the level node. Node 3. Then on level node we have 3. Is node 3 have any child node? Yes, which is 9 and 20, right? So we gonna push them to the queue, right? Queue.push node 9. Push the left subtree of node 3. Queue.push node 20. Push the right subtree of node 3. Okay, now the queue is 9 and 20. While queue is not empty, which is true, the queue size is 2, right? This one is level 0, then this one is level 1. That E is 0, E is smaller than queue size, which is true. So we get the current node from the queue, right? Queue is first in first out, so we get the 9. The queue.shift, because queue is v4, then the queue now have 20. Level.node push. Oh, I forgot to push this. Result.push level node, which is result.push 3. Now the result have 3. So on here level node push 9, right? It will be push 9. Then level node will have 9. Is 9 have any child node? No, right? So we just continue. Let E is 1. E is smaller than queue size. This is true. You get the node 20, right? Queue.shift, because queue is v4. Now the queue is empty list. We're gonna push the 20 into the level node. Now the level node we have 9 and 20, right? And is it 20 have any child node? Yes, which is 15 and 7, right? So we're gonna push them. Queue.push 15. Push the left subtree of node 20. Queue.push 7. Push the right subtree of node 20. Okay. Then level 1 we already explored all of them, right? So we're gonna push the level 1 nodes into the result. It will be result.push level node, which is result.push 9 and 20. Now the result is we have 3 on index 0, then we have 9 and 20 on index 1. We continue, right, to explore the level 2, which is this one. So the queue now is 15 and 7. This one is level 2. Okay. While queue is not empty, which is true, right? The queue size is 2. Then let E is 0, E is smaller than queue size, which is true. So we get the current node, right? We're gonna get the 15 from the queue.shift, because queue is first in first out. Now the queue only leave the 7, right? Then we push the node 15 to the level node. I think we just need to 15, then the level node now have 15. And because 15 doesn't have any child node, so we just continue. It will be let E is 1, E is smaller than Q size, which is true. We get the not 7. Q dot shift, because Q is V4. Now the Q is empty list. $15 and 7. Then that's all for the level 2, right? So we exit the for loop, then result.push level node, which is result.push 15 and 7. Now the result is having 3, 9 and 20, right? Then on the index 2 we have 15 and 7. Okay, so we just simply return the result. Exit while loop because the queue now is empty. Okay, I think like that's all for the diagram, right? Let's turn them into code. Level order traversal. We get the root. If the root is empty, we return. Let result is empty list. We return the result. Let queue is empty, or we can just starting from the root. Well, queue dot length is bigger than 0. Const queue size is queue dot length. Let level node is empty list to store all nodes at the current level. Okay, if the current node have the left subtree, we just gonna push them to the queue. And if the current node have the right subtree, we will just simply push to the queue, right? And after we explore the current level, what are we gonna do is push to the result, right? So it will be result.push level node, right? Then we just simply return the result. I think that's all for the DFS solution. Let's do the time and space complexity analysis. This one will be, I can say like this one is O head time, where is the head of the tree. Then for this, O in time and O in space. Or in time because we visit all nodes at least once. Or one time per push. Overall is O and time. Okay, I think like this all. Sorry, this one I think it should be, sorry, this one should be O and space, where N is total nodes. Okay, I think like this all. So overall for the DFS solution, it will be O in time and O and space. Okay, I think like this all. Let's move to the next solution. So for this, first we need to check if the root is null, return empty list, create stack and push the root with deep into the stack. While stack is not empty, create result with empty list as the result, then this one will be return the result. Then on here, while stack is not empty, get the current node from stack. Then we're gonna push them right to the result. So I think like it will be, we're gonna use the, hold on, I think you know. So we get the current node from the stack, right? Get the current node and deep from stack. Then if the result, the length is equal to the deep, push new empty array into the result. Then result with deep as the index, we're gonna push the current node into the result with deep as the index, right? If current node have left subtree, push to the stack. If the current node have right subtree, push to the stack. I think like this. Yeah. Empty list, then the root is now return result. Let Q is the root, while Q the length is bigger than 0, we get the size first, right? Q is first in, first out, so we're gonna use shift. Current node.file, then if first in, first out, then I think we can push from the left side, then right side. Okay. Q the list. Okay, I think that is all. Then we just simply return the result. Or in time. Sorry, this one is all in space because we need extra space for all nodes. Or in space. Or in time because we need to visit all nodes at least once. So overall for this will be O in time and O in space. Let's try them. Okay, let's submit. Yay, it's working. Let's see if the option 2 are working too, right? Let me type it on here. Stack is first in first out, so we're gonna use for. And because stack is default, we visit right subtree first because stack is default. If not that right, stack dot push. Okay, then on here, if the result length is equal to the div, we're gonna create new array, right? Result push. Create new array for new level. Okay, until that is all, then we just simply return the result. Let's try them. Okay, it's working. Let's try to submit. Not the leaf and the div is +1. Let's try them. Okay, it's working. I think like that's all from me. See you next time.